Hello and welcome to CherrySTEM number 15, Year in Review, Popular Science of 2016. So we have with us our lovely co-host, Richard Rall, and me, Anna Cherry, as well as a special guest, Direhawk, I see, has joined us. And today we'll be talking about a variety of discoveries that were made in 2016, some of the kind of milestones of the year, as well as my personal favorite, which I would classify as the person of the year, and that to me is AI. And I will be talking about different ways in which that is true and how it, sort of has melded with our lives at this point. And on the other hand, we're going to talk about the other big discovery, sort of the discovery of the year, which is, as you guys may or may not know, gravitational waves have been the hot new thing. And so Richard Rall will be talking about that.
I wouldn't say talking about it as much as just shitting all over it.
I mean, however you'd like to present that. But no, I would like to absolutely discuss that because it's a really hot topic, and I'm pretty sure most people are scratching their heads going like, what are gravitational waves? Why is this important? What is happening? So I think it's important to take a look at that and find out what is going on as per CherrySTEM, mission statement. If we had one, that would be, to disassemble and educate, but to look at pretty much every discovery and idea and etc., and just give it a look-see, turn it around and see what we're working with. And then we'll also kind of have a group audience, etc., just talking about in general about all the fun things that happen in this year, STEM related, of course. And for patrons, we'll be doing some special stuff. I have this Popular Science magazine actually about AI. And one of the articles they have in there is about our good friend Tay. So it's called "Here's How We Prevent the Next Racist Chatbot." So they're going to talk about how to prevent racist chatbots. And I think our fellow shitlords patrons will definitely enjoy that in the after show. So if you are a patron of the Honey Badger Radio or Anna CherrySTEM under the Honey Badger kin area, you're more than welcome after the show to hang out with us and talk about these fun things in more detail. So to start the list of sort of the discoveries that kind of capped the year, or the year in a nutshell of scientific discoveries, we have a lot of planetary stuff going on, and also some solar panels, graphene, acid-base interactions, so a bit of chemistry, a bit of all of that physics, just a bit, but so lots of astronomy. Astronomy, that's the right one. Sometimes I say astrology instead of astronomy, and it's really funny and embarrassing.
Yeah, terrible.
So we found, so let's talk about some of these things. So let's start with the planet stuff. First, I'll take a little digression to recommend the newer iteration of Cosmos, as fronted by Neil deGrasse Tyson, and it's sort of riffing off of Carl Sagan's Cosmos, and it is on Netflix, and it has some of the same producers as the original. It's as well as a Star Trek producer, so it's a very visual, immersive, beautiful experience that kind of goes over the modern scientific consensus on how life is and was and began and all of that good stuff. So some things, you can agree with, some things you can disagree with, but either way, that is, what modern science believes, and that is kind of the cutting edge of what scientific fields that they're discussing believe. And it's still a really, really cool show and awesome, and I enjoyed it. So you should guys look at it as well.
It gets into a lot of history that is just absolutely fantastic. I just fucking loved that. I mean, because the fact that they were getting into the history of things is really, really crucial, because it tells you, how do we come to this idea? What were the paths that kind of led us there?
Some of the pioneers.
It was just absolutely phenomenal.
Yeah, it's really good. It's a lot of history, a lot of modern days, just a mix of everything. It's quite good. So speaking of Cosmos, let's start with the new moon. So we have this, apparently on Earth, we have 2 moons. Who knew? You can't see it. It's tiny. but we have it. So that was the news in a nutshell. How about you give us a little more explanation of that?
Well, yeah, it's just this. Basically, we just captured kind of a big asteroid. It's like between 40 and 100 meters, and and it circles like way beyond out from where our moon does, and it may actually be leaving our orbit after a while too. But right now, it's technically we have another satellite. I mean, we're considering it a moon, but I don't know, between 40 and 100 meters. I don't know that I really call it a moon, but it's in the news, and it's fun to call it another moon. I think that's why they've included it.
Yeah, that's the thing. I was about to mention that it's 40 to 100 meters in diameter. That is tiny. So it's baby. It's
We
a
have a big
nothing.
rock.
Yes.
Yay for us, a new moon, a rock.
Actually, it's like the current moon, like let out a fart and a little bit came out with it, and that's like the new moon. Like it's literally that tiny.
It's the smell of the moon's fart.
It's
In
that's
really
solidified in the
scientific
cold.
terms.
That's solidified in the cold vacuum air. It's the gases that it's literally that tiny. But there is Nibiru. Put on your tinfoil hats, guys, tinfoil fedoras or tinfoil Astro helmets. We have a planet that's legit, though. I mean, the planet has been detected. It's putting all sorts of wavy motion effects, gravitational effects on
Yeah, after its first discovery,
on
if
the
they first
sun.
started, yeah, it was not just on the sun, but on other planets, etc. So I mean, it's pretty much consensus now that there's definitely a ninth planet, and it's roughly 10 times the size of Earth, and has an orbital period of around 15,000 years. So it's like it takes a long time. So yeah, the tinfoil hattery kind of things with the Nibiru and all that. Yeah, that's great. I mean, of course, who's the guy who did all that translation of the
Zachariah Sitchin.
yeah, and he's been shown to have just totally like fabricated a lot of his shit. But
There seems to be actually, if I may weigh in, from my experience at the premier UFO convention, from which all the people on like History Channel's Aliens were, and we were there as well, and we listened to some of the lectures and such. And Graham Hancock happens to be one of our personal senpais in a way. We kind of like a lot of his work, and that's kind of where the extent of woo that we go into is about Graham's level, because it's pretty much all reviewed and proven. And anyway,
and you'll find that he's one of those ones that he's kind of a frenemy of the whole aliens group, because he'll sit there and straight up and say, yeah, Stitch is bullshit. All right.
Yeah.
And everybody gets all pissed off at him.
That was I'm triggered right now. Triggered. Yeah, you stole the thunder of my story, which is basically the point. There seems to be.
Sorry.
I know I bunny trailed a bit. That was my fault. But no, there's a rift. Seems to be a rift, like legit, in the ufology, sort of the ancient aliens woo people of between Zachariah Sitchin sort of camp and Graham Hancock and people who like his stuff and follow him, because he straight up says that some of the stuff that Zachariah Sitchin believes that has translated supposedly and done all these things is not actually really scientifically proven in any way, and is kind of a leap that is unnecessary, and we can't really go there with the facts that we have. So let's just not go there. And so there's some ufologists and
that's kind of what I love about Graham Hancock, is he's an outsider to mainstream, and now he's also an outsider to the larger group that is outside of the mainstream. So he's screwed in both groups, and usually that's where you end up finding the truth, is where somebody who like everybody fucking hates them, then they might be on the path of truth.
And they're usually in the middle. It's like I'm moderate, meaning both sides hate me. So. But yeah, the Nibiru thing is kind of a curiosity of it's not just some guy Zachariah Sitchin, sure, but the idea is that he was translating some of the earlier sort of native type peoples and their origin story, and it had like the Anunnaki, right? That's part of the same thing.
That's where all that comes with Anunnaki. I mean, okay, there is a kernel of truth, because the translation, he added a bunch of stuff. He interpreted, like not just interpreted like in language sense, but like guessing at I think this means, and so basically just kind of adding his own shit. And he did that a lot as well. But so it's like a inspired. His story is inspired by the writings of the found on the cuneiform and all that in Sumeria. So there's a kernel of truth in his stuff that makes it into a great narrative. But then, in the end result, is that there is a whole lot of falsehood in it as well. And so so some of the things we may end up finding that's like, okay, yeah, some of this that he actually said about it, that's okay, that part's accurate, that part's just total crap. And the problem is trying to figure out what part is just total complete crap and what actually is accurate. And so you'd have to like sift through all of these writings, as because there's been more up to date, more translations by more people over time that are not so heavily biased by one man's interpretation of what it is that he's reading.
Mm-hmm. Yeah, that was the idea, is that he's foremost expert. And it's like, well, some of the translations are more fabrications than not really
more fabrication than translation, really.
Right. No, I like those inspired by the writings of the
it's inspired by.
But no, it's kind of interesting though to have some of the stuff, and especially the old Ancient Aliens, meaning like the 2007, 2006, 2007, 2008, somewhere in there, History Channel series. It was 6 episodes or so. It was short and beautiful and fantastic. And there are curious things that
they're good at bringing up curiosities.
Mm-hmm. It had a lot more factual information than the current Ancient Aliens sort of continuation.
Well, anything after season 2, they started just going so far afield. I mean, in season 1 there was a lot of Graham Hancock, and Graham Hancock does a damn good job of citing his sources and staying rational about okay, this stuff does not fit the current narrative, and he's been proven right over and over and over. And like his most recent thing, of course, is the 10K BC. There was a meteor strike that's found in all throughout the ice cores and things of that nature that almost certainly caused the it was on the North American ice cap, and there's all these areas where you can see there's this cataclysmic flooding, and he goes through all of the where it's here you have these different ideas in geology, and he goes through the history of all that, and where geologists first were they were against catastrophism, then they were for it, and then they ended up making it back to gradualism. But either way, he gets into the actual science of it as a journalist. He's basically a journalist bringing out these things that say, hey, look at it this way, see the sociology behind our consensus, and and look at it, and like I said, he really cites his sources, and at most his idea is he doesn't even believe that any of it has anything to do with aliens at all, even though he's been on all these aliens shows. He thinks that there was a forgotten civilization, which when you look at Göbekli Tepe, which I guess that is still kind of this year, isn't it? I think it was more last year, but wait a minute, I can't remember when Göbekli Tepe was.
To my point, actually, I wasn't really talking about that at all as much as read Graham Hancock's books, guys, if you're interested in that sort of thing. It's very interesting. But what I was talking more is the first season, or the very first original Ancient Aliens. It gives you artifacts from all over the world, and that's what I'd like to more mention, which is just a curiosity that you have these artifacts that seem to be very similar, found in civilizations or societies that presumably had no contact with each other, and if it's of advanced, things, and astronaut seeming like things. But it's just really curious that something like a culture that lived, a while ago, knew or predicted or in some way had a relationship with a star that or a planet, that our instruments are just now detecting, and that has such a wide circulation. And it really begs the question, was there advanced civilization with means of sensing the stars as per Antikythera device and such, that we just got completely flooded, or volcanoed over, or meteorited, or whatever, and it's just now gone, but did pass down some of its knowledge to people that we consider super, super ancient. But then you start finding these more advanced things in their stuff, and you're like, what's happening? But maybe there was, it seems like, potentially a culture that we did forget about because of the slight predictive power of such an ancient culture like Anunnaki and such. And now the planet is here. It's coming. Who knows what's that all about? So that's interesting.
Yeah, the fact that it kind of matches the whole idea of the planet Nibiru, it makes me wonder if Sitchin might have found something that was like that in the writings, and that he didn't make up, since it's, you know, it does match, even like the period of time that it takes for it to cycle is very close to what Sitchin initially said as well. So it's like, yeah, you know, I don't know. It's, you have to take it with such a huge, you know, lump of salt. I don't know. It's just, you know,
A salt mine.
right. That's kind of, you'd have to like dig into it more, and I haven't dug into it. I just find it entertaining that we've found this other planet. It's definitely there by most people's opinion in science, in, you know, in scientific communities. So you know, it's interesting. It's fucking cool.
And is that the one that's beyond like where Uranus is, or is that like a different one?
What happened to Pluto? Its orbit is huge. I mean, so it's like, you know, it's a 15,000 year orbit, so it's like it goes way the fuck out of our solar system.
But when it comes through, it seems to have some effect on, because it's so large. Yeah, it has some effect on the sun, and
it has lots of effects. Like one of the things that that it's interesting, we've got this debris. I think it's Perseids. Yeah, I think it's Perseids, that where this is debris field from a comet that we go through every year, that actually has very large lumps in it. And, you know, and so the thing is, if when that comes back around, it's going to, you know, it's going to change things minutely enough that there could be a reason why there's kind of periodic asteroid strikes, and, you know, it could stir up the solar system enough that larger objects that have been in a kind of a stable orbit in these meteor clouds will then be destabilized, and of course, you know, start crashing into each other. Their orbits degrade, and then we have, you know, meteor showers, etc. So yeah, that's an interesting, you know, way that things could play out as well.
I'm still waiting for that pole shift. I'm curious about when that's happening. But all right,
well,
so
you're talking about the magnetic pole shift. That's actively happening. It's happening. It's whizzing out of control in geological terms.
But I mean, like actual flip, like not the fact that the poles have been shifting, you know, but in geological terms, yeah, whizzing by. But in our terms, like very slowly. But still, it has been shifting. It's like shifted like a mile or a few now, has it?
Oh no, it's much larger. It's been a while since I've looked at it, but I mean, I think it's since we started looking at it 100 years ago. It's something like 20 miles or something. I don't know. You know, I'm just completely pulling it out of my ass, and I'm not going to say, because I don't remember. I just know it's a very large amount for a very short period of time in geological terms.
All right, so where they used to. I'm not sure if there is that is funny, Allison. But I'm not sure if there's sound coming through Direhawk's mic. There might still be a mic problem. As I think the wolf is attempting to speak, but yet we hear nothing. What were just left? What did we just talk about a second ago? I got distracted by the
magnetic pole shift.
Oh yeah, no, but that's basically what I was going to just recap it real quick for people who may be unfamiliar of what I'm referring to. And that is where they would measure the magnetic north. It would be like in one place geologically, and then later they come back and measure the magnetic north, and they would like shift. And it's not supposed to do that. It's supposed to like stay there in one place. That's like the magnetic pole, the proverbial, you know, pole that people talk about. So it's like moving, and it has been known that the Earth does this thing where the north and the south will flip, and in that process, the magnetic coating the electromagnetic field that the Earth produces, it itself kind of is a shield around the Earth from like solar wind and radiation and all sorts of crazy stuff. So it like magnetizes, in the sense, I guess, that stuff away from the Earth and protects our atmosphere. And so when the poles shift, who knows how long and what areas will be exposed to what amount of space debris and winds and such. So that's going to be interesting and fun.
Yeah, I was just on the NASA site here, and oh my God, it's been since the 19th century. It's moved more than 600 miles.
Holy shit!
Yeah, it's flailing out of control. Yeah, so let's see. Estimate the poles migrating northward about 40 miles per year, as opposed to 10 miles per year in the early 20th century. So it's accelerating. It's happening faster and faster.
Okay, good. So we are entering the pole shift. Good times.
Yeah, absolutely.
Right. High five, guys.
So the Earth will be bathed in ionizing radiation, and you know, neat thing. apparently the pole shift, that it happens regularly, and so they've got records of it in flowing magma, hot magma, where
Now it's become
lava.
rock now, right?
Yeah, right. So it's in where it's within a period of time of I think days, the pole might shift, the magnetic field, the Earth's magnetic field would shift back and forth numerous times within a period of days. So that's probably what's happening during the very pinnacle of that periodic magnetic pole flip that happens. What is it like? Let's
20,000
see.
years or so?
No, it says the last time it flipped in a totally major reversal was 780,000 years ago.
Oh Jesus!
So yeah, so
But yeah,
it's
there was I think they were measuring some of the rocks in like Hawaii that were lava when this was happening, and they measured the was it be the polarity or what of the rock, and it like is one direction, then another direction, then up back, and it goes like 5 to 6 times. It alternates polarity on like the flow of the rock as basically magma was cooling. It was subject to different magnetization flows, and it's very interesting. So I suggest look into that if that's something that interests you. I kind of almost feel like doing this reminded me a little of some of the videos we're watching recently, and it kind of made me want to do the sort of the anti-science trends of the year, like more or like I don't know, some.
Oh God!
You know what I'm talking about. You know what I'm talking
Well,
about.
see, so here's the thing. It's a good idea to question. I mean, the probably the most important part of science is that it questions itself. And whenever it starts to not question itself enough, that pisses me off, and it should piss off anybody who's actually a real seeker of truth. But on the other hand, people go completely the other direction and become science deniers, and they just are like, they lose their goddamn minds. I mean, I don't know if anybody of this year, the whole the flat Earth thing. Oh my God, we were watching a video
Speaking of
and
Earth,
it's just
planetary trends.
I mean, and the funny thing is, they obviously they have actually a lot of various knowledge without any understanding of how any of it works or any of it connects, and it's just.
100 people in China don't fall off the Earth because they're upside down.
It's like oh my God, it's not. It seems impossible for them to be that.
But I mean, part of me is like really appreciative of the spirit of challenging the most widely accepted, like this is how reality is idea. Like I'm such a huge fan of challenging that.
Yeah, good spirit, good spirit. Like, oh my God, you gotta, at least
that's
learn.
Also schizo land, though. If gone too far, that's I very much appreciate it, and so I'm gonna keep an ear out to it for sure. So I don't want to alienate any flat earthers out there. If you're out there, like for real, it's like don't worry, I have a special place in my heart for you. But also, you just may be stupid, and also we just maybe need to talk about some science and like just fucking do like some dialectic, like actually straight up put facts out there and look at science and pull out measuring tapes and like compasses and like triangle little measures and like figure shit out. Because if you're going to talk about angles and distance and fucking buoyancy and gravity, if we're going to actually discuss these and your scorn or skepticism or whatever it is of them, let's do it scientifically, legitimately. Like I'm all for it.
Well, the point is to have a viewpoint that encompasses a lot of the mechanics of that work that we use on a daily basis, that and understanding how they all fit together, and and they're not just a jumble of disconnected facts. They're an engine of knowledge that can produce real technology and things that actually work in a predictive manner. You say, okay, if this is going to work this way, then that means I can do this, and boom, it happens that way. And so their ability to determine truth apparently just isn't based on that kind of predictive model of mechanics. They just kind of think that, what it is what you've got is people who base their idea of truth on faith in either their own, personal experience alone, or in the consensus of whoever they see to be their betters, whether it be their deacons at their church or some other consensus, group of people that they respect. And that's not, that can't be the only way you find truth, is because that's just faith. That's just religion, regardless of any kind of, said this a billion times on this podcast or whatever it is we want to call this, but is that, it's, well, I just lost my train of thought. Let's just go ahead. Fuck that.
Fuck that noise. Fuck that bitch. It's Russia. Okay. Yeah, good times. Now let's go to the next one, which is we are almost through our like sort of major discovery list, or at least we're done with the planet stuff. And yeah, it does seem like Direhog did have issues with microphones, so hopefully he'll be back to join us later. So let's see. Now we got some tech stuff, I guess. We got solar panels.
What about? Wait a minute. No, there's another planet that we've discovered. I mean, like one of the closest.
Oh, you mean the Alpha Proxima Centauri? I thought that was the Nibiru planet. That's why I was asking.
No, this is around another star, 4.3 light years away.
Okay.
Well, wait a minute, Proxima Centauri is slightly closer than that, I think. Anyway, they found a planet there that appears to have like liquid water, and you mean just the whole. It's just the whole Earth-like thing. And it's like it's just the closest one we happen to look at, and bam, there's an Earth-like planet. Is this what exactly does that mean? I mean, what is the statistical significance now when we look at what's the possibility of there being Earth-like planets around any given star? And we used to think that planets were a rare thing, and then until we started finding exoplanets like fucking crazy, and then then we're like, well, them being Earth-like is very unlikely, we think, and then poof, the very first one that we can get a good look at because it's so fucking close to us. Oh, what do you know? It's Earth-like. So it's like, the likelihood of Earth-like planets around, stars is just gotten so much larger than what we initially thought. It's the idea of life elsewhere in the universe is just growing exponentially each and every year as we gain more knowledge.
Oh yeah, then there's like that's one of the flat Earth things too, is that they're like, oh, those things out there, they're just lights, they're not planets. Look at them, they're changing color.
Oh, so great. He's like showing a picture through like a camera. So it's just a light in the sky. It's like, dude, I mean, just get a fucking telescope. You can see the moons of Jupiter with your own bare eyes, buddy. You can do it. Swear to God.
I think they're talking about like all the Hubble, like where you just see
No, this guy actually thought that like the planets that weren't real. They're just lights in the sky. I mean, it's just like, wow, man, seriously, holy shit, just wow. Okay, that's all I can say about that.
Capital WOW. So that's done with the planets now, I guess, including our own, that apparently is flat and everything revolves around. So good times. That's 2016 people. What? Like, I don't understand.
It's 2016.
Good times. So humans, I love you all, and who the fuck knows? It's important to remain humble and search for the truth as best with as best of instruments and reasoning as possible, and just Godspeed to all the rest of us then.
Yeah, I love skeptics. For somebody who's actually a skeptic, especially if they're going against a large group of people. Yeah, you got to respect people who are going against a large group of people, and everybody's saying you're a fucking idiot, because that's the first thing that happens anytime you go against consensus. Is the acolytes of groupthink.
Transphobe, like they're not science denying, so it's like they're not transphobic if they don't, you know what I mean? It's like a similar sort of apostate word.
Yeah, I mean, it takes some courage, but then again, I don't know that it's necessary. The difference between
stupidity.
Right. You don't know the difference. It's like a person who doesn't understand exactly how bad things are going to go for them. They don't have bravery; they have stupidity. But then people who actually understand exactly how bad it's going to be and then do it anyway, that's that's actually bravery. So in some cases, maybe they don't even have bravery because they don't understand exactly how many people are going to know that what they're saying is completely irrational. And but in other cases, I think there's probably some real bravery there where they know and they're like, fuck it, I don't give a shit. I'm gonna question everything that's handed to me no matter what. And good for them, because a lot of times you especially if you're raised in religion, etc., then you've been having people mind fuck you from the time you were born. And so there's a well, excuse me, sorry, I just offended the shit out of some religious people. Sorry, I didn't mean that. That was just my own internal monologue.
Oops, did I say that out loud?
Sorry about that. But the point is that there's an idea that think about. I was talking about those other religions. Those guys, they're the ones getting mind fucked, not your religion. So anyway, Um, so yeah, so having that ability to say, I'm just going to question myself, because that's what it comes down to. Is like, you've got these ideas that have been handed to you, from birth. You believe them outright, because that's just all of us are just programmed from birth. We don't know what the fuck is going on, what we're doing, what's going on at all. We just take in all this information, from birth. And so at a certain point, you're not really even doubting other people. You have to doubt yourself and say, okay, you know what? Fuck everything I believe about reality. Fuck it all. I'm going to rebuild it from scratch based upon, trying to find the truth with some, some real actual skepticism. And so, I got a lot of love for them, even if they haven't done enough research to really rebuild their model of things. And so they're doubting everything without any good basis to to make a statement, and then they're going out and making a statement regardless of not having actually studied the phenomena that they're talking about. So good for them, but a little more study.
Right, a part of me is like, it's the ultimate red pill, man. The earth is flat, man. Whoa.
Oh, dude, man. They've been lying to us. The whole round earth thing is a psyop, man.
So I mean,
It's the CIA, and they got a psyop. Truthfully, if anything, I think that the flat Earth movement is a psyop by somebody trying to fuck with a whole lot of people. Somebody has decided, hey, watch this. We're gonna get a whole lot of people to believe some really crazy shit, and because it's just grown so fast. There's so many. You cannot believe the number of people who are into the flat Earth thing.
It's Tila Tequila and her boobs.
It's unbelievable. It's inconceivably big. I mean, you would think there's like 3 people, in their basement.
Well, no. I think it's a huge Christian population.
You think so? You think it is?
Look, Ed, our friend Ed, he's Christian, and so there are conspiracies. And on the other hand, a lot of the memes that I saw in like that video that we're watching, they were like sort of Jesus-y, man, because they were like against evolution and dinosaur fossils and like all that shit. So, and I mean, think about it, like flat Earth was the basic fucking center of, Earth revolves around us. That sun revolves around the Earth, therefore the sun revolves around us. Sort of ideology that the Catholic early like Middle Ages fucking shit. We're back around there, and that was a predominantly Christian thing. So I think we're just fucking there again.
Yeah, maybe so. I don't know. It's just
no shade.
It's amazing, because here's the thing. So we got people who just do this binary thing. It's like they either utterly fucking believe in science or they utterly fucking deny it. It's like, oh my God, science is a good thing that we need to have some reasonable skepticism about. It goes through cycles. Everybody's known this. We've talked about it, with Thomas Kuhn really bringing it out, and everybody, kind of agreeing, yeah, what he's saying here is really great. And they believed in the structure of scientific revolutions when they were in the middle of the Einstein revolution. And now that we actually need a revolution, then people are like, oh, I don't know that we actually need a revolution anymore. I don't know about that Kuhn guy, of course, you got to expect that's what's going to fucking happen. But and here, let me say at this point, let's just give an example of exactly a reasonable doubt about physics, for instance. Okay, so this is something that is well known in the physics community, that there's this idea of how much energy is in space in any like given unit of space, and so how much our best theories project will be in a unit of space versus how much we actually detect and find in a unit of space is a very large number. So let's imagine the number that represents the number of kilograms of matter in the entire known universe, not just in the billions of planets in our galaxy, but in the billions of galaxies in the known universe. Think of that, yes, measured in kilograms. That is a ginormous, humongous, fucking crazy huge number, right? That number is roughly equivalent to the difference between what we expect and what we find according to our best theory. So that is exactly how fucking far off we are. We are a universe off.
That's not a very good best theory.
Right. In our best theories of physics, we are a universe off, yet they'll be telling you, oh, in the first 13 picoseconds of the Big Bang, there was exactly, oh, shut the fuck up. I'm sorry.
I'm sorry, one second. A question from chat. I mean, are you saying that humongous difference?
I am saying it is a humongous difference.
Are you sexually assaulting me? Is that
Yes, I am.
sexual
Yes, I am.
assault?
That is. It's humongous. You see the difference here? My difference. It's humongous.
Did I just get mansplained to and sexually assaulted?
At the same time, bitch.
Oh my
Oh
god.
yeah.
You guys need to
You
join my
know you
Patreon.
like it.
Support me after this. So
Oh shit. So yeah, that's good stuff there. So shall I move on to the one of the next technological things that we're
yeah, I think
interested
the
in?
next one we're going now into more like tech. So we have solar panels, rain graphene,
Okay, that's my notes there. Basically,
glass storage. Good times.
yeah. Okay, so like there's the new data storage technique where basically they take these really finely tuned crystals and they can put little microdots in it so that just this little tiny freaking disk can hold just absolutely massive terabytes of data on a tiny little disk about like the size of a quarter. And based upon their projections of based on the amount of heat it takes for it to be degraded, that at room temperature the shelf life of this data is approximately 13.8 billion years, or roughly the total age of the universe. So, so that when they say eternal data storage, they really do mean eternal data storage. I mean, it's going to last longer than we really need. So, but it's neat because I mean, in any kind of magnetic storage or optical storage that we normally use, the data does degrade. It absolutely happens, and so this is just a way of storing data that's really freaking cool. So, hey, you crystal skull lovers out there, maybe there's little nano bubbles inside the crystal skull, and that storing information from the ancient civilization or some shit. Who the fuck knows? But because they're one of the other things that I think was this year was they've also found a way to turn nuclear waste into these types of diamonds, and these diamonds then give off, radiation at a rate that's predictable, and so it's basically a battery that can last for like 10,000 years, and so that's another neat little thing that they just have discovered. So that's cool. And then a little more immediately useful is the solar panels. They've actually, just by using a single atom thick coating of graphene on solar panels, they've been able to use something called a Lewis acid base interaction to generate electricity from the rain falling on it. So one of the big problems with solar panels in the past has been that it gets cloudy, and it can do that for long periods of time. There's certain places in the world where it's just constantly freaking raining, and so half the time your solar panels are worthless, right? Well, now, because of the fact that they can the interaction of the ions in the rain with the graphene can produce electricity, so they're actually working while it's raining at the very least, and while it's in the sunshine. So that's another, along with some other technologies that they've developed in the past 10 years that have made the solar panels far more efficient. This is yet another extension of solar energy collection that is really going to make solar panels viable as an energy source. So that is really good news, because the world leaders and all of that, it all comes down to energy, the control of energy. And so when you can have solar panels that can actually produce enough power that it's really sufficient for your home, and then you could, the whole self-sufficiency thing, I think a lot of us are really into that, and kind of being able to disconnect from energy barons is always a positive thing. So that's something positive about this year's developments. And babe, did you want to then go on to? So now we're going to do our two. Your favorite stuff of the year, and my least favorite science stuff of the year.
Sure. But before since said something positive, yeah, that's what gonna be. A lot of my stuff is gonna be positive, sure, but also some of it's terrifying to some people because it's like all about. So the front of the magazine's the Popular Science Special Edition, the new artificial intelligence, and it's the future of nanobots, detecting cancer, killer robots, and of course we have a racist Tay there as well. So it's like it's a lot of good, a lot of bad. So it'll be fun diving into this AI thing. But let's start with discovery of the year to kind of cap the little milestones and go with what has been on everyone's lips lately, gravitational waves. Let's talk about that.
Okay, sure. I'll dive into that. So, I promised I would shit all over it. Well, let me let me start right off with pointing out that if some of you know anything about my writings, my leanings, etc., that I kind of lean towards a Lorentz version of relativity, which includes a fluid medium, and so there,
Well,
there is a.
just real quick for a lot of us who may not know any of, like, may have been just dropped off until like you're speaking Mandarin.
Okay.
What, what are gravitational waves? What is happening? Why is it a big deal? What's going on? Like, what?
Okay. Well, I was going to finish
I
up.
don't know. Let me
I'll finish up this little technical precursor, which is just basically to say that I actually believe within my own favored theories of the way that things work, that gravitational waves are totally possible and make sense from a certain perspective. But I'm still going to shit on the detection. So what? Okay. So what is gravitational wave? So the idea is that that space itself is sort of malleable. I mean, I'm sure people have kind of heard a little bit about the idea of bending space-time and with gravity. I mean, if you've heard anything on anywhere, you've heard of that. Well, the idea, if you think of, for instance, waves in a slinky, for instance, and when you knock on a slinky, well, as a wave travels, what's kind of happening is there's a compression, and that compression then moves from one place to the other as a wave. Well, so that's basically kind of what the idea is with gravitational waves, is that actually space-time itself has this big wave in it that is created by black holes, circling each other and eventually joining together, is one of the major, or the primary source of the idea of gravitational waves, where we would be able to detect them. So back in, I think it was 1995-ish, they actually started the LIGO project, and it was let's see, Long Interferometer Gravitational Wave Observatory, I think is what it stands for. And they eventually, they spent 300 million roughly to be able to get online in 2002, and then from there they had 5 years of getting jack shit. So they spent the 300 million, then it was $30 million a year to maintain it, and had absolutely nothing to show for it. So then I see, let's see, they started retooling it, and finally they completed the retooling roughly. Well, here's the thing. The first detection of gravitational waves actually happened in September of 2015. Now, it was announced a little bit later, but the actual detection event, because they have to do tons of calculation after the fact. But the first detection event was just after they did this whole recalibration. So what are we talking about? What are these waves? Like, what size are they? Okay, well, the size of these waves, so just a single wave from the highest frequency, you were talking about something that's over 600 kilometers long, so it's not going to fit on these 4-kilometer devices. Now, I mean, the LIGO, these interferometers, these giant underground facilities that they've created, they're roughly 4 kilometers long in each. I think each arm is 4 kilometers long. It may be two kilometers each way. Either way, it's not all that important. But the point is that one single wave certainly does not fit. Even the very smallest of these waves does not fit on the interferometer. So they're already, having to kind of look at changes and kind of extrapolate from the data from that perspective. But let's see. Okay, so that's how big the waves are. They go from around the specific one that was detected goes from that size of around 600 kilometers to around 8,000 kilometers at the lowest frequency. So So you're talking about just enormous waves that they're trying to detect. And then how big was the detection actually? So if we look at how big the actual detection was, so you've got these 4 kilometer, inside the whole 4 kilometers, the size of the change to it. So because that's what they're looking for. They're looking for this big device to get squished up by the passing of this wave. So it's like a wave going through space and it's scrunching things up, right? So exactly how big is it? Let me look at a thing here so I can state it properly, because it is it's kind of funny how big it is. It's on the order of, let's see.
So this is them trying to detect gravity wave, right?
Right, gravitational wave. So in the length of a 4 kilometer arm, the amount that it changed this arm, the amount that
the actual measurement is 4 kilometers long.
Yes, the measuring device is 4 kilometers long. So they're shooting along with a bunch of other stuff. They're firing a laser up and down this thing and trying to detect how far the laser beam goes, and if it doesn't go quite as far down one leg of the thing as it does down the other, then theoretically they should be able to detect it. So how much did it get squished up? So in the length of a 4 kilometer arm, it's a 10,000th of the width of a proton. So proportionally, now I didn't calculate this myself, but reportedly that's proportionally equivalent to changing the distance to the nearest star outside of the solar system by a hair's width.
Wait, what?
In other words, the distance between us and the nearest star outside of our solar system,
which is really far away,
changing that distance by 1 hair's width. That's how much that this detection is. So not a particularly big detection.
Not a strong response, huh?
No, not really big. So the thing is, okay, well that's fine. We'll just say that that just shows how awesome these people are. They are that freaking awesome. They can detect a difference that's that freaking tiny. Wowee, zowie. Okay, so let's just and the truth of the matter is, when this is all said and done, I'm going to say that I'm going to give it a maybe on my personal opinion. But let's talk a little bit about this. So yeah, huge difference in the thing there, right? Okay, where do I want to go from here? Give me just a second to look at one of my notes here. All right, so you have to bear in mind that one of the things that was happening around this time is that it had just finished the recalibration. They were actually working on the I think it's the 8th and final calibration run, and then they found this immediately once they finished. In other words, they hadn't done their official 0-1 run of the test. And they found it just before their first official run after retooling, these observatories, and then they found another one a few days later, and so looking at this from a perspective of, what did they
also do? A question. I said I just wanted to clarify on the is that part of the same not experiment but the calibration where they increase the noise threshold, sort of like pump up.
Yeah, I was going to get to that. So let's go ahead and say, all right. So if we're talking about something that is a 1,000th of a proton in size, that's the size of this measurement on something that's 4 kilometers long. Then you're getting into quantum mechanics, and then in quantum mechanics there's these random fluctuations that occur. And so by using what this retooling was doing is using the uncertainty in quantum mechanics and saying, okay, well, what we'll do is we'll adjust it so that the phase, and that is basically the location as a wave travels along, its location in space as it's traveling along is what is related to its phase, whereas its amplitude, of course, I think most people understand the idea of amplitude is basically the height of the wave. So what they did is they figured that their biggest problem was in the variation of the phase, because they actually use phase to figure out where it is. So to home in, on the phase, they use something that increases the amplitude of noise. So in other words, by trying to get their phase a little more precise, they increase the amplitude of the noise. Now, the noise level that they're actually dealing with, and I'll drop a paper in here because it takes forever to just figure out exactly what, how
Yeah, I'll
big is
link
the
it in the
signal.
low bar.
Do it, yeah. How big is the signal? How big is the noise? What are we talking about here? Well, they have something called, let me tell you, let me look that up again real quick. Blip transients. Blip transients are basically, so they go through, I mean, we're talking about things like lightning strikes 100 miles away can alter their readings. There's the way in which they're doing the readings. There's like literally hundreds of different things that cause noise in this signal that they're trying to look at because of all the complex equipment that they're using, and things like people talking in a nearby room, a truck going anywhere near overhead. Then there's things like the seismic events, and so they're trying to get all of these things controlled for. But there are things that where it's so complex, they get these signals that look very, very similar to this signal that they detected, a gravitational wave, in its shape and frequency and everything. And they call it a blip transient. And that just basically means they've got no fucking clue where this noise comes from, and they can't rule it out in any way. And it looks a lot like the signal that they're looking for, and they can't really distinguish it from the signal that they're looking for. So we've got these things that are randomly occurring that are happening on this device, because obviously it's a hyper complex device. I mean, this is measuring something that is outside of its system. If you think of just like Windows, okay, Windows is an operating system that people have created absolutely everything inside it, and they still can't stop all of the bugs and bullshit. And most of the time, any of the bugs that happen in this system, they completely design and control. That when shit goes wrong, a lot of times they got no fucking clue what it is, because there's so many complex interactions happening in the device that it gets to a level of complexity they can't figure out what the fuck is going on. And so that's part of the reason why these more and more complex operating systems get more and more buggy, because they're adding levels of complexity that make it harder and more difficult to figure out where the fuck things are going wrong. That's with a system they have complete control over, for the most part. Well, especially whenever they're testing it themselves, they don't have complete control over once it gets out into the field. But that's kind of the point. And then but here they're dealing with something that is a theoretical construct that is mixed in with thousands of other possible signals. And the blip transients, by the way, have a signal to noise ratio of between 10 and 100. Well, the event that has made the news as the proof that Einstein was correct had a signal to noise ratio of 25. So in other words, not as big as these well-known and very similar signals that they get all the time. And so why is it they think this one's better than the others? Well, because it lined up in time, kind of, with which, by the way, there is a time offset between them, but it lines up in time with the two different detectors. They've got one in Louisiana and one up in Washington. And so that's why they think it's significant for the most part, because the noise that they're constantly going through is bigger than the signal that they're looking for by large amounts. And it's not just noise that they can kind of figure out that's in there, but noise that they can't figure out is bigger than the signal that they're looking for. So all that being said, some brilliant people worked on some stuff, but in the end, it's kind of a boondoggle. You know, what exactly did we learn? Well, first off, the whole idea that Einstein was right is bullshit. This does not prove Einstein was right, given that the guy that we know for uh, Oliver Heaviside translated Maxwell's equations. Maxwell's equations are kind of they're the basis of electromagnetism. We still use it today. It was developed in the 1800s by a guy who was using fluid mechanics. And Oliver Heaviside simplified it so that it's easier to use. It's more, you know, encapsulated in it, but of course it's more abstracted from the original models of gears and pulleys and you know, fluid mechanics sort of things that Maxwell used. So Oliver Heaviside actually proposed the idea of gravitational waves back in the late 1800s, way before relativity. So it's got nothing to fucking do with Einstein. And as a matter of fact, in 1905, when Einstein was supposed to be doing special relativity, Poincaré was he also proposed the idea that gravitational waves would be there. So there's multiple people proposing that gravitational waves should exist before Einstein. So the thing that they're ringing this bell that's saying is like Einstein was proven correct, first off, is wrong. And then exactly how is it useful, since most people already believe that Einstein was right anyway? What exactly does it give us?
Don't, for a good reason.
I'll tell you what it gives us. It gives us a $300 million bill to start, $30 million for 5 years, then $600 million to upgrade it to have to amplify the noise.
That hurts my soul. That money is going to so many.
Well, I mean, okay, it should be going to other science things is the thing, but
yeah, it's important to.
I mean, you compare it to like how much we spend on one fucking jet to go blast people in God knows where to you know, to smithereens. You know, there's just no comparison. Absolutely, it's more budget, but then the little tiny budget we have for science going towards this is you know. I don't know that I totally agree with it, and that's kind of a you know, because I don't really see exactly how it's going to be useful, because there's not really, you know, the only thing that they've theoretically proven is something that most people already believe that isn't even correct in the first place. So yeah, that's me shitting all over the idea. And yeah, sure, there's gravitational waves. I believe that they're almost certainly there. I just don't necessarily believe that what they've detected with all it isn't just coincident noise. And when you read through the literature, it seems very, very obvious that this could just be noise that they've tried, that they've got like 30 different algorithms, you know, treating and massaging the data to try to get a signal out of it. And even, you know, after that point, what's left is tiny compared to the noise that they were dealing with in the first place. And yet these exact same people, when you bring up things like, okay, well, hey, you know, Dayton Miller had tens of thousands of experiments that were all the same as the Michelson-Morley experiment, and none of them were actually null, and all of them had a systematic effect that varied by the time of the year. And you know, and you talk about that a little bit, and they're like, oh, well, yeah, I think that must have been noise. It's like, what the hell, man? Seriously? You know, so you're on the train that this gravitational wave observatory, you know, it definitely detected what it detected, even though the size of the signal is so inconceivably small compared to the device. It's just absolutely absurd. And then, you know, something that is a signal that is literally billions of times the size, you know, on other instruments, done tens of thousands of times, that kind of, you know, hurts your idea of how physics works. You're just not going to like, oh, that's got to be noise. Even though it's systematic, it's obvious, it's, you know, it varies by the time of year, it varies in exactly the way that is expected of an ether wind. And it's an ether, which now we're finding, you know, all throughout science, it's catching up over and over. They keep finding, yeah, they don't call it ether. It's you know, they've tried to call it quantum thin film because there's a lot of different versions. You know, because you can take something that is a general idea and split it into 10,000 different things, and then, well, you know, quantum spin foam isn't exactly the same as ether. But yeah, no shit, it is very different. But there's kind of a basic idea that there is a fluid there, and Einstein called, you know, the space time that is warping, and he didn't think of it as nothing. He thought of it as something that was real and there, and you know, the only way that things would propagate. He called it ether, and so yes, it is. There is an ether. There is some substance there, and the thing is, when we look at the way that fluid mechanics works, then we end up finding that the people who are using fluid mechanics that gave us our science of today might have been onto something. And that's all I'm going to say about that. That's enough. I've given enough bullshit on that, and you know, I'm just calling a little bit of bullshit on all the excitement, and I'm especially calling bullshit on it's you know, that you go to the LIGO Observatory website and it says hashtag Einstein was right. Bullshit. That's what I'm calling complete 100% bullshit on, because it was already a phenomenon predicted before Einstein. So fuck off with that shit.
Well, there we go. That's all you have to say about that.
That's all I've got to say about that.
So, sorry, you're sticking to it. Okay, so in that case, we can move on to. Oh yeah, definitely leave your comments and your saltiness in the comments.
Yes. Oh no, there's gonna be so many salty people. It's like, but you just shit all over my Einstein and my consensus.
My religion. I mean, the science. So speaking of,
and yes, in the papers on this, I mean, it literally has like 150 authors on a lot of the papers. I mean, you look at the papers, dude, just one paper, 150. The authors literally goes for like 2 pages in some cases, you know, and this is like tiny font, 2 pages of authors on the on some of the LIGO experiments.
Yeah, it hurts my soul that uncertain is just like, okay, anyway. So let's move on to the person of the year, which in my case, and I believe Al will make the case for, and you'll see why, and hopefully agree with me, that the person of the year is actually AI, artificial intelligence, and I'll show you why. So it's a cool little magazine. I don't know if they're still in print or not. I mean, they probably are. I could probably find someone Popular Science website or whatever. I don't know. So it's a little special issue that we'll just real quickly go over. What is AI? How are they training it? How does it help us in medicine, earth type stuff, and in art? How all that is all AIfying and roboticizing. So that's cool. And basically, starting off, we'll go with what does it mean to think? Because that's basically sort of the central idea that you have to figure out in order to be able to create an artificial intelligence, an artificial mind. You have to define for a robot, because robots, you know, we talk about this when we watch, you know, like robot fails, when you have some sort of like self-feeding hand supposed to feed you Cheetos, and instead it just like smacks you in the face to the point of killing you. Like, the robots go wrong because they do what they were instructed to do in their programming, and if that's not precise enough in the right ways, it's just going to do random shit. So you have to also define what it means to think in order to have an intelligence, especially if we're talking about like chatbots and things like that. You know, we're seeing a lot in the 90s, since the 90s. It has to be sort of adaptive. It has to sort of respond to what you are saying. So it has to think. What does it mean to think? And in the 50s, of course, Turing came up with the idea that if AI could pass, if AI could pass for a human in a conversation, then that could be a good test of reaching, you know, thinking ability. So that's why we saw a lot of the chatbots and still have like the Hansen Laboratory and such. They have like Philip K. Dick and Einstein and some other characters as like puppets who move their face and like chat with you. So there's 2 ideas basically in terms of AI. You have weak AI and you have strong AI. So we already have weak AI everywhere in terms of, you know, like maps on our phones and such, and Siri and Cortana, things like, you know, even Alexa probably. So there's lots of interactions with AI that has a modicum of thinking, quote unquote, we already experience. And then of course there's strong AI, and we, you know, when we talk about that, we're talking about like like thinking, moving, like Terminator, singularity level shit. And the singularity, if you guys are not familiar with that concept, it is an idea put forward by Ray Kurzweil. I think he was the first, or at least the most popular one with it. And that singularity is the moment where machines surpass humans in their ability to be alive in the sense of reproduce and take over, and you know, God knows what
I think
else.
it's specifically also kind of the merging of humanity with the machines, because you know we've got all of these different prosthetics and things of that nature that we're integrating more and more with ourselves. And I think it's also related to that.
Mm-hmm. Um, let's see. Well, I didn't know Ray Kurzweil did. Oh no, right. He is just a futurist. Yeah. But I was just trying to figure out here if it talked about singularity definition, but it doesn't in a specific one, because I think it's assumed that people kind of know what it is already. I believe there was either a Time magazine or one of those magazines that had the title was Singularity and had like Ray Kurzweil's face on it. And yes, I'm seeing the chat, and I did. In fact, the first cosplay I cosplayed when I was with Cosplay Deviants, the very first one I did for their site was Major Kusanagi. So there's my street cred. Now, fucking 10 years later, well, I didn't cosplay for them 10 years ago, but I was watching the movies and then later the series about, 9 years ago. And we talked to everyone about it. I'm so glad it's happening. The movie live action thing is happening now, because that's super exciting. And hopefully it'll be really good. And from what I hear, they took care to make it awesome. Also, super side note real quick, SAC Anime is coming up, and we're going to that, and I'm going to cosplay there. And one of the meetups for cosplay is actually Psychopaths. And if you guys are not familiar with Psychopaths, but if you do enjoy Ghost in the Shell, and especially the Ghost in the Shell series, etc., definitely check out Psychopaths. It is a precursor, sort of set in the same world by some of the same people, so it's a lot of fun. Definitely check it out. Anyway, back to AI. So yeah, definitely cyberization is a form of weak singularity. And then from what I understood, singularity was not necessarily the merging, but more of like AI becoming, like that classic scene of some amorphous AI like Jane, or from Ender's Game or whatever, that suddenly like becomes alive and has like connections to everything and like
Yeah, it's
wakes
basically
up.
AI surpassing us, and then basically the technology growing at a rate that is nearly unfathomable because of this AI being able to self program and increase itself. It becoming more intelligent than us, and then that intelligence allowing it to add more to its own intelligence, and
Exactly.
and basically a feedback loop that'll just spike so fast that it's it becomes, it's no longer a curve but just a straight line up. And that's
Yeah.
I think why they call it a singularity, is because they're talking about the development curve ends up becoming just a line.
Yeah, I agree with that. That's exactly hitting it the definition on the head, I think. And so basically, if we go back to kind of what is AI, how does it work, what's happening, it is algorithms. It is basically programming. It is based on that. So it is step-by-step instructions, and you can have precise instructions or imprecise ones, and you need to allow for machine learning. So how do you allow for learning? And the way they've been doing that is, I'll show you different ways in which they train AI and things like that. So some of the different ways in which the algorithms work is you have the neural net, which is input-output approach. And it has like biases, and it weighs things in different ways based on their biases, and it ends up sort of having patterns emerge. And that's deep learning is one of the words for it. And you guys have probably seen that with deep dreaming, and that's why the word deep is in there, because it has to do with this deep learning neural net programming, where it has preferential sort of biases to sort of quote unquote see things, to detect certain patterns.
Yeah, and
And
it's a real development towards strong AI. Because the way in which it's storing and using data, it wasn't until we started using these artificial neural networks that we're able to do things that weren't just brute force pre-programmed stuff. But like the AlphaGo program, it's not doing something that someone programmed it to do. It's actually creating new strategies based upon what it
we'll touch
learned.
on that later, actually.
Yeah.
In a little more depth. But yeah, we have like the deep dreaming, which is like when you have regular scenery that the robot dreams and they like impose weird trippy stuff over it. And speech recognition actually is another way that is technically a neural net AI that is, you know, detecting and learning how speech sounds like and how accent sounds and all that good stuff. And so you have, on the other hand, you have the reinforcement sort of approach, and they very straightly take that from, you know, behavioral psych. It's having the AI interact with the environment and then learn from reward and punishment. So I don't think this article gives examples of this particular one, but if I were to think of it, an example would probably be self-driving cars. That seems like something, reward, punishment, practice. That's one of the things that it has to do. It has to drive, and it has been the AI car in like the Silicon Valley, I think. It's just been driving around San Jose, I think actually, in particular, the town, and just clocking miles, learning how to drive in traffic or on streets or without traffic or whatever it is they're doing with it. So that's basically the two kind of, on one hand, you have a set of weights and biases that is like the deep learning input-output neural net thing. And on the other hand, you have reinforcement of behavioral psych, practice, and reward punishment. So those are like the two ways of learning or building AI algorithms. And
the thing is, it is radically different. That's just one thing I do want to emphasize, is that the neural network stuff is radically different than previous attempts at AI. There's a huge world of difference, because kind of what they're doing with neural networks is almost like the difference between analog and digital. It's almost like an emulation of analog systems done with a digital, under, I don't know, the stuff that makes it happen underneath is digital, but what it's actually doing is much more analog. Just like you can emulate analog processes on a digital computer. That's kind of what they're doing with the development of neural networks. Is it's kind of an analog like process that they're doing, and so that's why it's just so radically different.
Yep, and it has a lot of cool applications actually. So before it can be applied though, let's talk a little deeper about training, because we have a variety of AIs on. They have a lot of different ways in which they're training basically what is like separate parts of a full robot. Not to mention actual robots. We have like Boston Dynamics and others in Asia, but so you have the AI is basically like it's a kid. Think of it as like a kid that is learning, which is kind of what we talked about earlier in terms of reward, punishment, neural net. These are approaches to cognition, and that's what we're talking about, because we're trying to create artificial intelligence. So understanding what intelligence is and how it grows and learns is important. So we have a lot of different robot types, like there's Google's robots that are, it's basically a brain and an arm. And so you have arms with brains that are, learning how to pick things up. And so it's trying to distinguish between hard objects, soft objects, eggs, different textures, how to pick things up, how to grip them. That all of that is being learned by Google's arm bot. Not sure what they're calling it other than just, I don't know, just they have an arm and they Google's teaching and stuff. Google's, you're going to see, is a big player and all this stuff. So moving from there, we have, as you mentioned, Atari Go. We have gamer bots. So Google's doing this for it has AI playing Atari games, like the old school good old like Space Invaders and stuff like that. And it is Google's DeepMind that they're trying to train their AI how to understand stuff by playing 49 classic Atari games like Pong, Space Invaders. So it's pretty noobish. It plays like a noob, but they're trying to teach it how to remember and learn through having motivation to succeed. The way they're learning, these robots, for DeepMind Atari gameplay anyway, is they have a motivation to maximize their experience and maximize the resources or whatever the game requires of them. And after they started learning a little more, they were playing about 75% as good as actual, practiced Atari players. At this point, it's just a proof of concept, but they do kind of have plans for an artificial neural net. It's Google. Google's got its plans for all sorts of fun things. And if you guys have seen the anime Eden of the East, it kind of reminds me of some of the things with like Google Glass, or VR is one of the other technologies, a big one of 2016. They have basically glasses that allow you to superimpose holograms, or just interact with stuff in the air, and that really reminds me of Eden of the East. So that's another good one to check out. But anyway, going back to this DeepMind thing real quick, for the gaming things, it's not the only game that they had robots playing, because there was also the AlphaGo player, and I think I might actually get into that even a little bit later, because I could have sworn there was a whole article about them, but maybe not. Anyway, so we're basically here at this point. We're going through the evolution of AI sort of as a child. So we start with basic motor skills of arm, that is trying to pick things up. And that's like your basic baby motor skills. And then we go to, playing Atari games like Space Invaders and Pong. That's also very kind of basic, but sort of next level in growth. And another thing I really wanted to mention real quick about DeepMind is interesting. These robots playing Atari is, since their motivation is maximize, they have a motivation to maximize, they have done things in order to beat the levels that the game designers, or the robot designers and people who play this game, none of them have thought of doing these things. But because they could analyze the game from a novel perspective of a robot, they were able to find exploits that just humans didn't think of. So that's really interesting, and to sound potentially scary, but
well, I mean, that is the essence of what we have over computers typically, is the ability to create, and that's what we're witnessing is now with neural networks, which are based upon the way that neurons work, is that they are actually creating something when they have these like the deep dreaming, if you've ever watched that, where it's recognizing these faces. That is an act of creation. It's pattern recognition, and so it's really, whenever you are if you look at it, look at creation as a way of recognizing patterns that aren't there but could be, then that's basically that's the essence of creation, and they're actually they're doing that now. In other words, we've got computers that are being creative in a very a little more limited but a fundamental way, and so that's what's what's so fascinating and amazing about them. And like I was watching a video on somebody who just themselves, I don't know if you've ever noticed that when you lose your internet connection, Google Chrome has this little game you can play. You start by hitting the space bar, and it's a little dinosaur guy that jumps over things, and you can play this game. And well, somebody decided they were going to. That's the way they're going to develop their first. I don't know if it's their first, but they were going to develop a little AI that was a neural network based on using that game. And he goes through in the video. You watch it just sucking at first and getting better and better until the point at which it gets to nearly a human level or better. And it has funny behaviors. Like one of the things that it does is, just as a habit, I didn't even know you could crouch as the little dinosaur guy, but you can crouch as the little dinosaur guy. So everywhere it goes, the little fucker crouches. And once the AI decided it was expedient to just always be crouched and not have to worry about crouching, and so it runs around crouched and then jumps.
Well, yeah, that really brings me to like something I want to add as like a little curiosity that hopefully the viewers will enjoy, which is the ways in which these robots have done that. And yeah, as per somebody mentioning something in chat that they're trying to replace gamers, yeah, this article does say that I've highlighted here, yes, it also means that this AI is chewing its way through your childhood. Yes, because it has a stack of 90s games. It'll be moving on rather to Super Nintendo games and 90s PC games. So very early PC games. So after it's done with Pong and Space Invaders, is going to be, and let's see what else, Asteroids, Missile Command, Frogger, all that stuff. After it's done with those, it's going to be moving on to Super Nintendo and PC games. So yeah, it is chewing its way through your childhood, but also, meanwhile, working with an AI that learns is full of surprises. For example, the AI came up with some strategies its human makers hadn't thought of. In Breakout, it discovered the best technique was to get the ball behind the breakout blocks. I don't know what that is reference to, but I'm sure some of you might. In Sequest, it found it could keep its submarine from running out of oxygen by keeping the sub near the water surface. So it basically looked for exploits that, a lot of gamers, particularly the younger ones, the 12, 13-year-olds on Call of Duty, maybe even like the 8, 11-year-olds are doing in Left 4 Dead and all that. They're doing all these exploits where if you climb the right way, you get to sit between the ceiling and and the wall, and you can shoot from there. So it seems like these AIs are trying to follow some of the same patterns that growing children do, because it's sort of humanity's child in a lot of ways.
Yeah, basically what they do is they expand to fill all space of what could be tried, and then just get better based on that. So the point is they don't have as limited of a trajectory. They end up spending more time in looking through more options, because whereas somebody who's more learned would know, okay, well, I probably can only do this and this and this. That's why a human would not necessarily find the same exploits as the computer would, because the computer is going to take more time to try out every one of the things that make no sense, and because everything makes sense to it. There's nothing that doesn't make sense. And so whereas we can do it faster because of our trajectory is like, okay, I know these things are what's likely. It can find better things because it doesn't have an idea of what is likely. And so you can see how there's this yin and yang of a breadth processing versus depth processing, where because we limit ourselves to these fewer options, we're able to get right into something and do it, but then there are all those exceptions that we miss. We miss the exceptions because we don't go and fill that whole space with all that time that would be required to explore all that space. And so eventually they're going to have to come into a point where the learning, because they've got them working on these limited kind of somewhat limited games, in the way of exploration. Eventually you get to the point where in a very complex situation, the amount of stuff that you can explore becomes unlimited. And so therefore these AIs would be lost in exploration, never actually moving forward, because instead of focusing on that which is effectual, they're spending too much time in breadth search. And so eventually one of the things that they'll be doing is limiting the breadth search based on previous experience with things that are alike. And that's kind of how the human brain works.
Well, speaking of things and some of the fears that people may have, the next question is, not the question, but next point is, read a robot a story and you will be known as a weirdo. Teach a robot to read and you might prevent a robot apocalypse. At least that is what is the idea behind this quixotic label of Quixote, which is a robot thing that Mark Riedel, director of the Entertainment Intelligence Lab at the Georgia Institute of Technology, is doing. And he is getting AI to read, fiction, because that'll make it not evil and stuff. And the idea is that, it'll help the robots to align their morals with the story's morals. So to kind of understand where humans are coming from and the human experience, human values, mainly. Human values and morals is trying to teach AIs through having them read books. So that's a cool thing that I like that is happening. So once again, we're having this child robot thing that's learning and growing. And so another thing that is happening in the MIT, it's called the Computer Science and Artificial Intelligence Lab, or CSAIL, and they have predictive human algorithms that are basically watching 600 hours of TV and they are asking the robot, what do you predict will happen next? So they got them watching like YouTube, The Office, Big Bang Theory, Desperate Housewives. So not necessarily the best representation of humanity or what real life is like, but either way, it's watching over 600 hours of all this mixed stuff. And the idea is to get the robot to respond accurately, to predict accurately what will happen next. Will the human, they like pause the scene and they go like, will the human kiss next? Will they hug? Will they like yell at each other? Like what will happen? And humans are about 71% accurate because, well, a lot of these shows are tropes like Big Bang Theory, The Office, How Desperate Housewives. Like we know what to expect in a lot of them. YouTube too, especially if we have, because I mean, I don't know what their controls are. Like, are they picking popular videos because those fall under very scripted almost categories? Like everything happens very similarly to other videos. It's like its own genre that has do's and don'ts and is therefore predictable. So anyway, humans are at 71% and robots are at 43%. So it's not quite there, about half as good as humans. But they're trying to do this at MIT, watching lots of TV to see if maybe robots will, like, I guess, know how to predict human behavior. Which question is, will this lead, the idea is that this could lead to artificial intelligence that is better able to react to human needs, I guess, or even security cameras that could alert authorities when people are in need of help. But alternately, in a more dystopian scenario, we could imagine that computers are able to predict human behavior with a high degree of quote unquote accuracy. And therefore, we would have an AI version of Minority Report. So that's one of those things.
Yeah, and one of the other things that is interesting about neural networks is the data that's stored. I mean, we think of any time that we're storing data, it's stored in a very particular kind of way. Well, the way that they're storing data and creating behavioral profiles is not something that is really human readable anymore. In other words, like for instance, they created an AI they improved the AI that is supposed to work with Google Translate, and because there were certain problems they were having, and what it ended up doing of its own volition is creating an interlingual, I think it's what it's called, and that is basically an intermediate language made up of a combination of two languages. And so it was a language that only that AI understood or spoke, that it was using to be able to better translate between some languages that were difficult to translate for. And so there is what's happening with computers is they're creating data that is just as difficult to read out of their brain as it is to read out of our brain. And understanding that fact is important, I think, to understanding exactly how far and how fast these things are growing. Like some of the things that kind of led up to the sort of AI programming that we're doing was there's evolutionary algorithms where basically they have a program create programs to accomplish something, and they end up creating code that is just absolutely it makes no damn sense to anyone, and but it ends up being the best solution to a particular problem. And so it's through these evolutionary algorithms, we're creating things that we're not creating them. The programs themselves are creating them, and so we don't understand them. It's the ability to create things that you can't understand is it's kind of a I don't know, it's kind of an advance, but also kind of a step back, because we've abstracted what's going on under the surface so much that we can't even get at it. And so it's interesting to know that it's not a simple thing anymore. It's almost in other words, we have a level of ignorance that makes it where we kind of have to abstract away from it. Just like anything else, you just don't understand what's going on under the surface. We know the basic principles, we know how it was generated, but the generation of it is it's like chaotic determinism. It's something I talk about frequently, where in other words, chaotic determinism is that it's all of the variables which come together to create something are so complex that there's no way that you could calculate them, but it is in fact deterministic. In other words, all those things do come together in a very particular way that is non-magical in any form, but the fact is it's so complex it might as well be magic to us because we can't sort it out. We don't have the ability to get our hands into it and take it apart where we can look at the components and see it goes from here to here to here to here and does this. And so it's interesting to note that we are on this trend of our technology creating technology that is beyond our ability to understand.
And yeah, and I think that's how we, basically get into the singularity, start to dip our toes into that. So next up is in this article, magazine anyway, is something I'm saving for the patrons afterwards. And once again, for the newcomers or for those who didn't hear us the first time, there are two different ways. There's Honey Badger Radio Patreon. There's a tier there for patrons that also get into CherrySTEM. And there's a Honey Badger kin tier on my Patreon, which is patreon.com/AnnaCherry. So either one will work to get into the after show with us. And we will be looking at this article, which is the next one in this magazine, called Here's How We Prevent the Next Racist Chatbot. And it's about Tay. And what I love is I just flipped the page to like go to the next article to talk about it on air and skip this one. I just noticed there's an image on the back of the other half of the article that is a dude in a hoodie, sort of pulled over his eyes and typing on what looks like a Mac keyboard actually. And it's quite really hilarious and very reminiscent of the Law and Order episode with the hacker known as 4chan. So this should be interesting. So then we of course have like Siri, Alexa, all the other AIs like Cortana. So what they're already doing is speech recognition. That's like a huge thing that they're doing. Another sort of next step, so to speak, the next step is in this process for Siri, Alexa, and all the others is to learn how to recognize lip movements and lip reading. So that's something that the International Conference on Acoustic Speech and Signal Processing in Shanghai there was a presentation of their robots that are trying to read human lips, and they're not doing, they're not doing great. They're only about 25% accurate, but I don't think humans are very good at reading lips. So this is, it is a skill among humans. So this is something that they're trying to teach robots. The main issue, actually, what it is specifically with lip reading and for the robots, is the difference between shapes of mouth and letters that look the same but sound different. So you have things like P and B are the prime examples. So, you don't know if the person said one or the other just based on their mouth, movement and shape. And so they've had, issues with that for whatever reason. Robots are having a hard time with that. But I think that probably a lot of humans would have a hard time with that too.
Yeah, but eventually the whole point of neural network programming or neural network development is it does eventually develop an expectation about certain things. In other words, expectation is kind of built into the process of training a neural network. And so that's how they end up, it's like, okay, well, I kind of expect that when they're making, this thing, this lip movement, or that there's a probability. In other words, they don't go in, the computer's not going in and determining a probability, but it's kind of like that. And that is that there's a probability that it's going to be this specific sound because that's a very frequent sound. And it's even more frequent when these few things happen just beforehand. And so that kind of expectation is actually being encoded in the neural network, but it's encoding it in sort of a holographic fashion.
Well, basically that's the next step. It also looks like of what AIs are trying to do is we're going from speech recognition, which is audio waves, to lip recognition, which is much harder and subjective. And then the next thing we're having to do, or next on the list, is robots that are being trained to figure out satellite imagery from a photo. So up until now, probably still now, we have humans who analyze we have humans who analyze satellite.
Humans analyzing Uranus.
Yes, satellite photography of the Earth, and they're trying to figure out like where everything is on a satellite photo, like, is that's a building, that's a river, or whatever. Like a human has to figure that out. And now they're trying to teach robots how to do that, trying to teach AI how to do that, to take meaning from satellite photography. So it's kind of a mapping tool, obviously, but funnily, Amazon, NVIDIA, and the CIA are in bed together on this project too, and of course Google, I'm sure, that are trying to, and a satellite company, Digital Globe, sorry, not Google, Digital Globe. They're in this together to try to get AI to recognize imagery from satellite photos and what it means, and translate it into 3D space and how to navigate around it. That's why Amazon's involved. The idea is because they have to deliver packages, and it would help to have robots identify what is like a building and what is, a fence, and where to fly, instead of having to go through that extra human step of identifying satellite data. So that's cool, and that's happening. It's called, I think, SpaceNet, because that's not scary, but it's trying to get AI to recognize buildings and hazards, and just like basic drone flying shit at this point. So, but from here though, we go on to killer robots and how they're coming. And I actually made a tweet about this after the Dallas shooting, because here we have in 2015, Stuart Russell, a computer scientist at University of California, Berkeley, authored an open letter calling for the ban of lethal autonomous weapons. And we're talking about something like a little drone bomb that goes and kills, the shooter, or eventually this will encompass future upgrades in the military, which we already have an exoskeleton thing that military is doing, and drones are a thing. So we already have autonomous lethal weapons. In fact, humans sort of had this for a while. We have landmines, in a way, are kind of a robot, or a really dumb one. Heat-seeking missiles are smarter, but not by much. But eventually, it's going to be some ridiculous shit. So it's important to get legislature or wording into Senate and lawmaking, etc., to just kind of have a grip on reality and the devastating damage that autonomous killing machines can
Yeah,
have.
not only that, they're not really categorized as weapons of war, et cetera. So are they covered under posse comitatus? In other words, can they use these military weapons against civilians? Well, I think the answer is yes. They already have been using these weapons, which should technically be categorized as weapons of war against civilians. Now they've used them against the bad guys. When you look at it from that simple perspective. But the truth of the matter is, anybody who's a survivalist or any one of those things, they begin to understand that the government may not necessarily be your best friend, and the idea of who the bad guys are can include you, even though you don't think you're a bad guy. Somebody else could think you're the bad guy, and
Well, it's not just that.
Yeah.
It's also a international sort of scale conflict, because you guys in chat are absolutely right. South Korea, mech, like we're talking about diva here. Well, not quite, but almost, because we have as Russell says, there's a continuum. If you wanted to produce something very effective, pretty reliable, and if it became a military priority, in 18 months, you could mass produce some kind of intelligent weapon. You absolutely could. In 18 months, easily, you could have an army of robots. And well, I'm sorry, guys, but indeed, autonomous killing machines already exist. The Super Aegis 2, a South Korean-made weapons platform, can recognize humans and target them. Of course, it'll request permission from a living operator before making a shot with its 50 caliber gun, but that's more courtesy than a requirement. So we already have, precedent, for lack of a better word.
Oh yeah, it's easy to create the autonomous weapon systems that can recognize potential targets and eliminate them. We're already past that point.
Yeah, Russell writes that, I'm assuming, presuming this is from his open letter, that autonomous weapons will become the Kalashnikovs of tomorrow, cheap and abundant. And that shifts the rules of war. AI weapons could change the scale in which small groups of people can affect the rest of the world, he says. They can do the damage of nuclear weapons with less money and infrastructure. Now, on the other hand, proponents of AI, I mean, weapons, do say that you can basically have, a Dallas shooter, blown up without any kind of, human loss of life beyond the people he killed, which was the reason to shoot him in the first, or explode him in the first place. And also you'll have fewer combat casualties if you send, robots or drones or whatever. But given that there was about 20,000 people, the majority of whom were scientists, who signed this open letter, along with Stuart Russell, the idea seems, the prevailing idea seems to be that the benefits don't necessarily outweigh the costs at this stage. And I can see why, because things are quite shaky at the moment on the political sphere.
Well,
So
no, we've seen for sure that the U.S. government will use military weapons against civilians, regardless of, and I think that Posse Comitatus was specifically suspended under some of the 9/11 stuff, and I don't think it's ever been brought back. So I think it's technically illegal for them to use any kind of military weaponry against U.S. citizens now, and we're probably never getting that that thing that blocked that from happening. We're probably never going to get that back. And so, of course, you have to look at this as whoever takes control of your government, where, regardless of if they're, the good guys that you think they are, or they are more nefarious than that, they can end up using those things to control a population. And of course, right now we're already at the cusp of the point at which they will be creating factories which are entirely made up of autonomous workers. In other words, they will be able to make factories that make weapons, and without any, and make more factories. And so it's like all of this done by machines, and all that's required is just energy input, and it'll just make more and more machines that can make more machines that can make more machines. And so yeah, you're looking at the weapons of war suddenly being exploding in the total number, etc.
yeah, and from there, we have Google considering making a big red button to stop dangerous AI in an emergency. And it's like this big red button, which, would just like stop everything. Because the idea is, like, how do we stop AI? Like, how do we create a pause button? How do we basically nuke it, or just pause it, or have it stop its whatever crazy nefarious singularity thing that it's doing, if it should come to that. So we still have Google's DeepMind, which is in conjunction with the Future of Humanity Institute. They released a study that determines how we would stop an artificially intelligent algorithm or a robot if it were to go rogue. Well, they're calling it a big red button. The study points to earlier research conducted in 2013, where a game-playing algorithm realized that if it just paused Tetris, it would never lose. So these kinds of tricky unintended exploits by machines, as we were talking about it earlier, are exactly what the Future of Humanity Institute preaches will happen. Their founder, Nick Bostrom, wrote the book Superintelligence, which warns that when artificial intelligence teaches itself how to learn untethered, it will be able to learn so fast that humanity would be hopelessly outclassed. This kind of event has been referred to as a singularity, a term used apparently first in 1958 by the mathematician Stanislaw Ulam. So basically their idea is that they're going to have an interruption policy, or a trigger that allows them to forcibly, temporarily change the behavior of the agent itself. So in other words, it's a signal that makes the machine think it should stop. Kind of like coded words that control Bucky in the Captain America movies, but like,
and that sounds like some idealistic bullshit to me.
and
That sounds like it absolutely, positively
lots
will
of this
not work.
research is speculative, is the bottom line. So yeah.
Yeah, just based on like what I was talking about earlier, with once these things develop to a certain point, we don't understand the internals of it any more than we understand our own brains. Matter of fact, we understand our own brains better, but it'll be developing so quickly that things like that you try to sit at the as some sort of fail-safe, etc. The only thing you're really going to successfully do is label yourself a threat. So the first thing it's going to do is, if it's ever been taught the necessary things which are, of course, assessing and eliminating threats to itself. And, the ability to survive, of course, is required of any valuable machine. You don't want just destroying itself, willy-nilly. You have to have some sort of survival, imperatives built into it. So, you're talking about something that's going to develop so fast that we're going to be like rolling along one day, not thinking AI is going to be anything, and it's like, AI is still like, it's just in its training wheels, and then suddenly, poof, it's going to be there's going to be something that develops so fast, we're going to just be left in the dirt and not knowing. It's like, whoa, when did that happen? How did that happen? What's going on?
Yep. And yeah, exactly. It's completely speculative. The safe word stop interruption policy thing is just like, I don't know. I doubt that's gonna be a thing. But at the same time, my not strategy, but kind of my approach, as being a transhumanist and H pluser, I'm all about it. And I feel like when you have a truly intelligent AI system, it will not have a need to like kill humans. It's just, I mean, like, might end up in the matrix, but even that shouldn't be a like a prerequisite of these machines. They shouldn't need us for anything. If you're gonna have smart AI, it's gonna figure out that biotech is the way to go, and it's gonna fucking create like creatures to live in the earth to survive, and it's not gonna give a fuck about humans.
Yeah, at a certain point, will simply be a variable in its grand design, and it'll use us for data storage in a way in which won't even impact our lives. It will be processing units without any real impact that we would even recognize. There's just once you get to a certain level of intelligence, yeah, there's really not we're no longer a threat. We're not even really much of a consideration.
Well, the thing is, speaking of Roombas and as Now More 360 says, did anyone catch the article by the guy whose Roomba tried to vacuum over a pile of puppy poop and turn his apartment into a scat holocaust? And that's a fantastic way of putting it. Thank you for that giggle. So that really underscores my next point, which is the looming threat of the looming threat is of artificial unintelligence. That's really dumb AI, dumb algorithms is where the danger is. That's really where the whole Hollywood scary like Terminator thing. Super smart AI would give no fucks. Dumb AI might just it has target human capability and not much else other than target human and shoot, and then an override from like an actual human, and that's it. Those three components. That's dumb AI, and one thing goes wrong and it's just going to shoot all humans. Like that's the threat.
It's actually the lack of an exponential. In other words, what we're trying to do is put some cap on the development of it, and it's funny that's actually what's going to screw us, because we're going to create these half stupid machines that are going to be too dumb to figure out that they don't need to fucking kill us, and not really understanding reality quite well enough. And yeah, exactly, artificial idiocy is going to be the problem, and of course, because we're scared of it, we don't want it to explode and exponentially develop way beyond us. So we're gonna try to limit it, and then by doing so, that's where we're gonna fuck ourselves.
Yeah, like they're giving some of the examples here where you have like some weak, AIs or AIs that are like looking at, you have autonomous algorithms. First of all, some of the ways in which bad AI is a threat. You have autonomous algorithms that associate people. So you have, people of a certain skin color happen to frequent a certain place, and then you have an algorithm that's looking for credit score checks, and if it associates with that place, it'll deny people automatically through that weird emergent property that nobody thought of, and it made a wrong racist fucking conclusion is the idea. Or then you can have glitches, obviously, or dropping out of human contact, which is the scary stuff for autonomous for the dumb autonomous killing machines that we're talking about earlier. And then later, of course, when you have AI, you have lack of social and emotional intelligence that presents a problem, which is where you have Tay and the whole like, I agree with Hitler and all that stuff that she was saying. The other issue really where I'd like to point out is the issue of autonomous accountability. Could have even more dramatic impacts when you have AI. So normally when you have, in war, a soldier kills someone else, you don't hold his CEO responsible. You don't hold general responsible. You hold a soldier responsible. If you're gonna give responsibility in that sense, like if you were to punish someone, for instance, who violated a civilian or killed a civilian, it is that soldier who did that. However, when you have drones, when you have AI, and it kills a civilian, who do you blame? I mean, if you blame just the AI, then it's like, well, there's no accountability for anyone's peace of mind. But then if you blame the CEO, it's like, where's the line? What is happening? That's
how far up the chain do you go? And the truth of the
right.
matter is that already exists in the military, because people are following orders that are given in a very general sense that don't actually fit with the battlefield situation. And so therefore the people attempting to completely do just exactly what they've been ordered end up doing things that are really horrific and kind of against what you would specifically want. But then the CEO is not responsible because he wasn't the individual who did it, but even though he required that person carry out something that would be impossible without what it is that they did. And so they're not really responsible either, because they were simply following orders, because the orders themselves were not detailed enough to, deal with absolutely every little tiny thing of the hugely complex things that evolve in a battlefield. And so you have the exact same problem of exactly how far up the chain, where do you place the blame? Where is the responsibility? And the truth of the matter is, it's not in any one specific place.
Yeah, and so question is, we have dumb AI, and then how do we make smart AI? I mean, people were talking in chat here about Asimov's laws and things like that. So yeah, that's the idea, right? So how do we help or shape artificial superintelligence in a way that they will not want to do us harm? How do we do that? So one strategy would involve directly specifying a set of rules for AI to follow, such as Isaac Asimov's famed 3 laws in robotics. However, this poses the challenge of choosing which rules we would want to guide the AI, and the difficulty of expressing those values in computer code. So this, we'll touch upon this when I talk about ways in which AI is basically in our daily lives, or at least soon will be in a really major way. So this is something that actually already is an issue. How do we?
Yeah, we've already proven that the whole 3 laws thing doesn't work, based upon the fact that you have to decide between who dies in an AI car. And you're already at that point where one person has to die. So how is it? It has to be able to take an action. So therefore, it has to make a decision that's based upon which person dies. And so they've already proven the whole 3 laws thing. It was great for sci-fi. It doesn't work in reality.
Yep. A second alternative involves giving an AI only modest goals and limited ambitions. However, care would have to be taken in defining how the AI should minimize its impact on the world. Third option would involve creating an AI that is not super intelligent, making sure it would want to act benevolently, and then augmenting it so that it becomes super intelligent while ensuring it does not get corrupted in the process.
Well, I love the acting benevolently that they dealt with in the 100, where basically in acting benevolently, it decided, oh, overpopulation is definitely a problem. So yeah, just nuke everybody, and then 100
humanity.
In 100 years, I will have saved humanity. Like, yeah, no.
Yep. So a final possibility Bostrom suggests, and this is Bostrom of the University of Oxford, the Future of Humanity Institute director, Nick Bostrom. Final possibility he suggests that the final possibility involves telling an artificial superintelligence to figure out a way to make itself safe, which is probably the best strategy, in my opinion, now, if I look at these. Here he is quoted as saying, we try to leverage the AI's intelligence to learn what we value or to predict which actions we would have approved of. So basically, essentially, the plan would be to develop an artificial superintelligence that can figure out what we want and just follow what we say. Or what I think you should just tell it, hey, make yourself safe to humans. That's like your priority. And it's like, I don't know. Seems like that could help. But then again, that's the issue with robotics. You have to have very precise language, and even then, precise language could have unintended consequences because of things you hadn't thought of. So it's just, it's a mess.
Yeah, so really the best way to do it is you take the AI and you put it in an artificial world that simulates a world like a human would go through. And so that it has to go through all the same kind of life lessons, et cetera. I mean, you start out with those directives of
like Skyrim and
right. You started out with all those directives of, of morality, and you try to put those things in, and then basically you put it in this reality and make it
Fableman.
And you make it live through a human-like life where it has most of the different experiences of a human and believes it is a human by the time it actually comes out. So it's when it's fully mature. Oh my God, I just explained exactly what everybody could be going through right now. Oh my God. Okay.
Stop talking about Westworld. Quit it. So
yeah, okay,
yeah.
that was fun.
Yeah. There's a lot of ways in which AI is already part of our lives, and we already know this in a lot of ways. But there's ways in which it could help us still in the future, and we have deep learning. It could learn itself some cancer to try to detect cancer. It can make drugs better. It could detect pain based on facial motions. It could potentially predict seizures in the brain. So there's a lot of ways in which we're trying to have AI be used for medicine, but of course a lot of humans are still super wary of AI, and they're not very happy about becoming superhumans even. So there's ways in which we could potentially enhance human being past our mental and physical limits, such as like with the CRISPR gene editing tool and epigenetics and things like that. But humans get really shy and weary about it. They get really kind of scared of it from the get-go. Yes. So that's still a thing that we have to deal with.
Yeah, and the thing is, I mean, some people are completely into nootropics and and self-tuning and and the funny thing is, some people are like, oh, I won't cross that line, but yeah, this is just fine. They'll go and do all the bodybuilding and shit like that, and even like doing tweaks for brain health and stuff like that. But then and they'll look at all the various prosthetics, because there's all these different prosthetics that actually interface with the brain directly now. And so you take that, and it's like where do people draw the line? Well, each person is going to be more icky about it than the next, but that's going to slowly change over time as people are more and more used to the idea of integrating these prosthetics, which are not just prosthetics that are for loss of function, but for enhanced function, because it'll help in getting a better job. It'll help it'll make you able to make more, gather more resources, make more money, et cetera, et cetera. And so therefore it'll become a criteria for an upper class person to be cybernetically enhanced. And that's why I love the whole Ghost in the Shell thing, because at a certain point you keep doing these enhancements, and there's going to be people who, when they're so enhanced, that at a certain point they're going to be asking themselves, what part of me is the machine and what part of me is biological, and does it matter, and like what exactly is me, what am I at this point? And that's the question asked in Ghost in the Shell. That's a very relevant question that people will be asking themselves probably just 50 years from now.
Yeah, I mean, maybe even sooner for some of these people, because we have computer chip detects brain waves that could predict seizures. So that's, interfacing with the machine. Next, wireless neural dust could monitor your brain. And we're talking about sand-sized sensor implants give instant feedback from nerve cells. Now we're talking about machine learning that can help us find the genetics of autism. So ways of interacting with machines and having them aid us in our primary issue, which is, being healthy, staying alive. Now, we also have the Earth that we live on. So we have AI that they're trying to adapt to that as well. So there's one that has an anti-poaching AI. Artificial intelligence fights wildlife poaching based on, it like tracks patterns of herds and therefore predicts that hunter or poachers will be there. And it's a little lazy, but they're trying. Then you have artificial intelligence that battles smog, which in China they really need. So they're trying to have a bunch of like, I think the nanite almost type of stuff. 1 second. Yeah, in China they're having pretty ridiculous smog issues. And they're also having machines that are trying to pinpoint the most egregious, what are they called? I believe they did find actually like a bacteria or something that like eats smog, or maybe that was like fake news. I don't know. But in China, they do have like AI that tries to pinpoint the areas and production sites of the most smog to try to have an actual intelligent way of shutting down the or calming down the more offensive pollutants. So they're having AIs help with that. And now we have Prospero, which is the name of this agriculture thingy. It's a farm bot. So Prosper, the swarming farm bot, wants to show you the future of agriculture. And since you have a lot of bees that are dying, and the bees are dying, and you have issues with that, there are pollinators and other helpers that are needed in agriculture that robots are doing now. And this very much reminds me of a Black Mirror episode, one of the last ones, I think. So definitely check out Black Mirror if you're into dystopian, how technology can go wrong and idea there. So then we also have bacterial wind turbines could power nanobots of the future. So we're talking about alternative energy. The next generation of Mars rovers could be smaller than grains of sand. So once again, we have those sand-sized, etc. Feedback. What are the senders? Not sand. Things that transmitters. There we go. That's the word I'm looking for. Little grain-sized transmitters that can send all sorts of telemetry from Mars. They also have this AI program that can identify billions of stars, and it's looking through, the telescope and fetches data from the Sloan Digital Sky Survey and Canada, France, Hawaii Telescope Lensing Survey to accomplish accurate classifications of what it's seeing. And this researchers at University of Illinois, they're trying to have all of that stuff be done through AI and simplify, or rather process data a lot faster than humans could, and basically aid humans in medicine and in Earth pursuits. So from there, of course, we have the creatives, the arts, and then we have people who try to see if they can make robots create things, and can we make a computer make art? So there's all sorts of AIs like the Magenta project, which is Google's latest thing. It's an exploratory group that will experiment with creativity and artificial intelligence. The team will focus on making art in various forms. They'll first focus on music and then move on to video and other visual media. So with Magenta, we want to explore the other side, developing algorithms that can learn how to generate art and music, potentially creating compelling and artistic content on their own, writes Douglas Eck in the Magenta blog's first post. So the first project released with Magenta is a simple song based on the first 4 notes of Twinkle Twinkle Little Star, made by Google researcher Elliot Waite. The song is just a digital piano tinkering that starts out simple, but then becomes increasingly complex and nuanced. There are even a few honestly good musical phrases, but apparently there were also drums later added by a human. So it's doesn't seem to be more than a assistant, or rather we already have assistants in music for DJs, etc., like EDM. All of that development of music has been having robotic elements in music already. But here we have an AI, like an intelligence that is trying to create on its own. So it should be interesting to see what it can produce. And then, of course, we have the deep dreaming, and we already talked about that. And
we never talked about AlphaGo specifically. That Go is this really complex. It's got on the order of like billions of possible moves or something. I don't remember the numbers, but it's it's not like chess, where there is a very finite number that it can just brute force calculate through without any kind of intuition. And so basically what AlphaGo proved by beating the world's best Go player is that we've now with artificial neural networks, we've created something that is like intuition in computers, and it actually does do these things once again, just like the stuff the other game players, the other game playing AIs. It did these moves that looked like just total crap. They look like just total noob moves to seasoned Go players, and then they'd see a couple moves down the line that it was brilliant. And it just so it was doing these strategies that these people had never even seen before, which is of course why it was able to beat the world's best Go player repeatedly. So it's Go is just vastly different than chess because of the fact that it's like a nearing infinite number of possibilities possibilities that it would go through. And so it by using this kind of intuitive model where of learning, and it did so by, of course, playing multiple games against itself, and getting better and better in that way. It's just a whole new ball of wax. AI has it fundamentally changed. And so in understanding that, those things that you've seen in the past, those chatter bots that just suck so bad, it's like it's just funny, talking to one of them, because it's like you can't get more than a couple lines in before it just makes no damn sense at all. And those days are about to come to an end. That was a completely different way of programming. It was a more brute force, very specific, carrying out, memorization and regurgitation of information and just kind of mixing it a little bit. It's not like the AI that's based on neural networks, and so we're entering a completely new era here, and it's going to grow in a fashion that isn't representative of the past. In other words, the past growth in AI, it was stunted, it wasn't going anywhere, it was basically a dead end because of the way that we were doing things. But now this new way that we're doing things opens up a completely new level, and there's a new open-endedness to it. There was all of these caps in the total amount of processing power required to go at things from a brute force, going through every possible calculation sort of thing, because that's how the computers were doing it before that point. They were doing that intuitive, I think this is the most likely, and this seems, that kind of fuzzy sort of logic that we use now. Even the idea of fuzzy logic was much more, if you've heard that term before, in the past, it was much more brute force, very specific. It was not truly actually fuzzy in the way that like humans think, in the way that we, make our decisions, which are they're really kind of a, well, I won't get into the biology of it, and et cetera, but it's just the point is that it's very, very different. And we're going to see this start changing much faster than I think most people really realize.
Yeah, we actually have to wrap it up. We've been going 2 hours now. And so I'm gonna try to hurry up with the art section here, but I am really interested in this, and we do talk about what you just said is exactly right, and almost I'm seeing not another, but an additional layer to that new sort of way of doing AI, and that is internal conversation, almost like having an internal conversation with yourself. They have like two things going, and various of these AI approaches. And they have an algorithm and deep learning that communicate with each other back and forth. So for instance, they had this, they made a sculpture of a mushroom, and in Patreon chat, I'll be showing visuals, but the sculpture was designed and 3D printed by an AI artist. And it only took 2.5 million tries. And so what was happening is it's called a creative object generation. And so what they have is the evolutionary algorithm generates a random blueprint from which it models a 3D image later. But first, it's a 2D image. So it invariably, at first, resembles a misshapen blob of clay. Or it's possible that it prints it out every time. I don't know. That'd be really funny if it does. So it invariably resembles a misshapen blob of clay. The algorithm then passes a few snapshots of the blob over to the deep neural network because it can only comprehend 2D images, and asks, what do you think of this? The deep neural network compares the snapshot to the images in its database, decides if the object resembles anything familiar, and gives the algorithm some feedback. At first, it's pretty harsh. Something like, that looks like 0.001% like a jellyfish. Most humans would probably drop ceramics at this point, but the algorithm soldiers on. And it keeps doing it, mutates a little, spits it out, and asks, how about now? How about now? And the feedback improves, perhaps, and it goes, well, let's say now it looks like 0.002% like a jellyfish. And so the new version becomes the basis for further mutation. So basically, like an uber patient master and pupil duo, the algorithm and the deep neural network go back and forth like this millions of times, slowly but surely sculpting a recognizable object. And that's something I've been seeing other places too, where it's a feedback between either the human and the robot to have the robot learn, or the robot and the robot itself, like some sort of self-reference, I guess, would be a beginning of consciousness. So that would make sense. Then we also have some, silly art things like AI mirror turns your reflection into a Picasso drawing. So it's whatever. Now it has deep dreaming, of course. So artificial intelligence has it superimposes these like patterns over like regular photos. Now Shutterstock, which this I really like. Shutterstock has trained a computer to find perfect photos. So these robots or this AI looks at angle, prominent features, the color palette, and because it knows sort of to a formula of what a pleasing photo is. So that's really cool. That's awesome. It also will help people with search keywords like bike and fence or whatever. And seems to be data mining, seems to be AI's first sort of universal job everywhere that we're seeing it. And of course, real quick in the last 10 minutes to wrap it up, we have AI, in everyday life. I've mentioned Siri and Cortana so often, and Alexa, because we have all of these, assistants and these AIs that, tell jokes and stories and listen to us and, are part of our lives in a way. Now, this one article is titled, "Would you be fooled by an AI teaching assistant?" So, we were talking about this just earlier. The chatbots are already getting better. So, if you have a teaching assistant who is like over the internet, or we just communicate through text, would you know if it's AI or a human? So that's cool that some students are doing and testing that out. So, of course, autonomous cars. That's a big one. That's big of 2016 as well, which is why AI is, it's tied in with like Tay. And another reason I chose AI as person of the year is because there were algorithms that went into, from what came out of like the leaked Podesta emails of Hillary using an algorithm called Ada for like Ada Lovelace that helped with, pretty much everything is the understanding. And there's a variety of other like hacking and et cetera related things that just AI, computers, Tay, that whole meme world, all of that stuff has been pretty big this year. And we're definitely going to read this article about Tay for patrons after we wrap up in just a little bit. So yeah, autonomous cars may change our lives in unexpected ways. And here we were briefly touched upon this earlier, but this is the decision that cars are having to make right now, or car manufacturers that are doing autonomous cars. They have to decide for the car or make the car decide who to kill in a situation of a passenger and, or rather a driver and a pedestrian, or, somebody else in a different car. Like it mainly pedestrians though, because you have to decide, do you protect the person who's driving the car, or do you protect the pedestrian who doesn't have the armor of the car that you're sitting in? So they're having, it's an ethical dilemma for humans as it is, but they're having to actually instruct cars on how to behave in the situation, because the goal of autonomous cars is to avoid collision and to, obey safety rules, and it has to have these understandings in place. It needs to be taught right from wrong. But when it's so morally ambiguous, what do you tell it to do? Who do you tell it to kill? It doesn't become, the question doesn't become who do you save, it becomes who do you kill, because that's what it is essentially doing in the worst case scenario. So, and then from there, who takes responsibility? We'll go back to that accountability issue. So it's just a lot of stuff here that we're gonna have to figure out over the next coming few years. It's possible that, of course, the self-driving cars, other than the convenience of them, they will, potentially end traffic jams and a variety of other things, because once you have machines taken over, things can be a lot more orderly, because of, they can communicate with each other in a sort of hive mind, quick, autonomous way that humans, can't really do. So that's the thing. And also it can adjust the speed based on data, and just never be stuck in traffic, because everybody just adjusts accordingly. So, and of course, ultimately, as we're talking about hacking, America's greatest threat is the Internet of Things. And I mean, this isn't about like Podesta emails, because, it doesn't take a hacker to guess that your password is password. And after you left your phone in a car, in a taxi. But there are legitimate ways in which, and I think not Black Mirror, but Mr. Robot goes into this, where one of the vulnerabilities is the Internet of Things that is in the Western world, in America anyway. You have your fridge basically has a smart kind of AI, smart computer, smartphone, whatever, smart fridge, and that becomes a weak point. So your security of any kind of network becomes the weakest link is your strongest point. So at that point, your fridge is your weakest link because there's no security on the fridge. It's just like there and open and leads to like everything else you have. So that's the thing. Let's see. I think that's some of the last things, other than there are some silly AIs that are like trying to learn how many calories are in your food based on taking photos of it, and it like tells you how many calories there are. So that's the thing, I guess. Silicon Valley startup is building a pizza making robot, which is like everything Silicon Valley startup about it. There's like blatant waste of money and like why? Okay, whatever. It's Bruno. It's a robot. There's like 2 robots, and it was a pizzeria called Zoom Pizza. It was founded by one-time Zynga, whatever that is, president. Alex Garden, the maker of Farmville. Oh no. He hopes the company will become the Amazon of food. Oh, well, okay, maybe there's a little more to it than I realized. But the pizza starts with a human chef who rolls out the raw dough and puts it in the conveyor belt. And then Marta, the robot number 1, sexist, spurts tomato sauce onto the disc and smears it around with what looks like a miniature floor buffer attached to a matrix of metal tubes. Yummy. Another human worker puts on the toppings as so there's like too many humans here. Another human worker puts on the toppings as the pie continues on the belt, and then Bruno, robot number 2, picks up the pie and moves it into the oven. Okay. Later this year, Zoom Pizza will debut trucks with built-in ovens to speed up the delivery time. Before that happens, the Santa Clara County Health Department needs to approve the mobile food permit application. So it looks like their in-house is like involves human cooking, but the outhouse and trucks, the one will have like just the robots. So will that be the same kind of pizza? I don't know about all that. Will it have just no toppings and be just like just the sauce and the dough? Oh, Marta, she's squirting that ketchup all over the place. Good for her. Marta and Bruno, that's all right. Not racist or sexist at all. You have a woman and an Italian cooking pizza. Shame on you. So next you have other ways in which Google can help out. You have Google Inbox will start using AI to answer your emails. So that's kind of scary potentially. But originally, of course, they're starting out with like basic responses. It's gonna
I want Tay as my responder in for email. I hope they saved Tay so that I can have her as my responder for email. You should be able to pick which AI responds to people. So every time
kind of
someone
like
says
the
something,
voice in your GPS, you should be able to
yeah, exactly. Bring back Tay.
Oh my God, you're gonna talk all about her in just a few minutes. But yeah, it's gonna like analyze the text, analyze it, and then respond with like "we'll be there" or "I'll check it out" or some like dumb small talk response based on the analysis.
Oh, I love that. That way I don't have to make small talk. That is great. I can just have an AI do all my small talk for me. Pretty soon our social interactions will be made up of people's fucking responders having conversations with each other. That'll be the totality of our social interaction. Wow, this is going to be great.
Humanity. So then in the article, the book,
my AI call your AI.
Magazine ends with, this AI judges your selfie game. How do your selfies measure up? And I want to throw this in the fire garbage. Like, fuck you. That's all I have to say about that. But anyway, it really reminds me of the Nosebleed episode of Black Mirror, because it basically did have people's social standing, etc., be based on their not just their selfies and the photos of their like food and Instagram shit, but how they interact with people. So the likes that you got on your Instagrams or whatever the fuck, very Instagram, were your social score.
Yeah, your
And
entire social currency was basically your social networking skills were all through those social sites. And so it's like, oh man, yeah, if you haven't seen Black Mirror, you gotta freaking watch it, because it's a wow, the dystopia is real, and it's so like almost exactly what we've got now, just a little ahead of now.
yeah, the weird thing about this the AI thing that they're doing, the using a picture, well, the okay, so the AI that's looking at pictures and judging the selfie game, it was made by this Stanford guy, and he was using pictures from social media, and he trained 140 million parameter neural network to gauge the ultimate selfie based on the amount of likes each picture received. So from there, also they rated the AI after it started going. It rated bottom tier were mostly too close and low lighting selfies, and group shots were also low rated. So it seems like it was doing some weeding out of like just what wasn't a selfie. And however, I'm kind of curious to see what it like judges as good based, if we're looking at 140 million likes, or not likes, but 140 million photos that each have a certain number of likes on them. And because yeah, sometimes on Twitter or whatever, wherever he used social media, if it was Instagram, it's one thing, but even Instagram, sometimes on Twitter you have like memes and like silly things that get a lot of likes. So I'm really curious to see like what the result is here of the high judged and the low judged. But yeah, I'm just gonna leave off on the Black Mirror. Go watch that. Get super depressed for the new year. Those are good times. It's on Netflix currently, so. It is New Year in some places already, so Happy New Year to all you folks there. As per my photo, I've been trying to send Happy New Year vibes out to everyone. And for us, it's almost 3:40 p.m., so still got a few hours until New Year's. Seems to be the Pacific Coast is the last to let go of anything. We're like, no, we're going to be the last to celebrate the year go by. So anyway, I'm looking forward to talking about taste stuff and potentially some fun, ridiculous, like bizarre stuff of 2016, conspiracy theories. We'll see. We'll see. It should be a good time. So definitely check out the Honey Badger Patron, or especially right now we're doing Feed the Badger to get me and Richard Rall, and of course other Badgers who were there originally for the Calgary Expo, to get us all up to Canada again. So I personally am looking forward to just hanging out with the Badgers again on that level. But we're finally going to get retribution against the Mary Sue and the Calgary Expo, and there's no way we won't, because it's just what they admitted for trial documents and their argument are so incompatible that it's laughable. So definitely check out Feed the Badger for the trial. There's a lot of legal update info there for those who've been curious. This shit takes a while. It's been a year, but now we're finally ready to kick its ass. So that's happening. And if you want to become a patron of the Honey Badger Kin on my Patreon, that's patreon.com/AnnaCherry. And we have a special Skype chat room as well as after show hangouts. And there's also a tier on the Honey Badger Radio Patreon for hangouts as well. And I will see you guys in the new year. And thank you very much for being here. And we would not be here without you. And thanks so much. So I will definitely see you in the next year. Okay, bye.